All right, good afternoon. Happy Friday. Let's get this going. Today we're talking about the quadratic formula. Okay, so we're kind of continuing talking about factoring, talking about solving, but more specifically using the quadratic formula, when to use it and how to use it. First, part A of the Explorer says solve the following by isolating the square variable, then taking the square root. You know what? I'm going to make this bigger. And we're back. So what am I going to do here? It said to solve by isolating the square root, or excuse me, by isolating the squared variable, squared term. All right, that's our 3x squared. So to isolate that, I'm going to add 5 to both sides immediately. So squared equals 970. Excuse me. We're going to want to continue to isolate the square term. By now, the square term's by itself, but the only thing stopping me from taking the square root of both sides is this 3 here in front. So I'm going to divide both sides by 3. Squared equals 3 goes to 9 3 times, 3 goes into 7 twice, remainder 1, 324. And then I take the square root of both sides to get x equals plus or minus 18. Boom. That was the first one. All right. Remember, you can always solve by using a square root or by using this method if all you have is a squared term and no x term. Okay, just a square term. Here we can't solve by using a square root because we have a square term and an x term. All right, so it asks us to solve by factoring. So I can do this two ways. I'm going to use a box method. I know a lot of people prefer that. So I'll throw the box over here. Boom, boom. I get x squared in the top left, negative 3 in the bottom right. If I multiply diagonally, I get negative 3. So I need two numbers that will also multiply negative 3 and add to negative 2. Those two numbers have to be negative 3 and 1. So negative 3x. I look for my GCF in the first row. GCF here is just x. GCF down here is negative 3. GCF vertically is x, and it's just x. So my two factors are x plus 1 and x minus 3, and that's equal to 0. Remember from our last lesson, or last time we did a lesson, not on Tuesday, but last week, last Friday, I can set, once it's completely factored, zero product property says that I can set each factor equal to 0 and solve. Some of us may be able to do this part in our head, and that's fine. Some of us need to write it out. I'm going to make sure I do both for you so you can see, all right, x is negative 1 and x is positive 3. And there you go. That's factoring. That's factor or solving by factoring. Okay. I would always try to solve by factoring if your square term just has a 1 in front of it. If my a term is a 1, all right. If there's just a 1 here and I need to factor, I would try to do that. That's going to be the easiest way. Can the following equation be solved using techniques from A and B? So first of all, I can tell that I cannot solve using the technique from part A because there is an x term and a squared term here. So my only other option is to factor it. Okay, unfortunately, there are no factors of 11 that'll add to 3. 11 is a prime number. The only factors of 11 are 1 and 11, and I can't add those together negative 3 at all. So can they? No. And I just kind of explained. We can say because 11 is prime. That's one reason why. That's enough of a reason for me. All right, today we're talking about when you need to use the quadratic formula. What's the correct order of operations for simplifying a solution with the quadratic formula? Okay. Quadratic formula you've seen before, x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And here's an example of how to do it. Okay, we've done this before. All right. What I wanted you to understand is when and how to use it. When to use it, how to use it. Okay. If I'm looking at something like this here, Okay, it says use the quadratic formula to solve, then do it by factoring to confirm your solutions. Now, here's the deal. I could do it either way. All right, I could factor this, or I could quadratic formula this. All right, there are going to be instances where both of them work. Okay, there's going to be times where factoring does not work and you have to use the quadratic formula. All right, but for some people, okay, using the quadratic formula can be easier than factoring something like this. All right, it can be. It's just a matter of fact. Okay, process, just doing the process. So, having said that, I'm just going to use the quadratic formula. If you find that you're one of those people, that's fine with me. Okay, if the question just says, "Hey, solve this," that was just the question. Solve. Use a method that you see best fit. If you don't want to factor it, then don't factor it. If I ask you to factor, you obviously have to factor. Ask you, pick your method of choice. So the first thing we have to recognize in order to use a quadratic formula, we have to identify our A term, our B term, and our C. A is a number in front of x squared, B is a number attached to x, and C is just the lone number. So we want to use our formula. As you can see on the previous page, x equals the opposite of b. So the opposite of b is negative 11, plus or minus the square root of b squared. So 11 squared minus 4 times a times c. That's all over 2a. All right, so I want to keep going. The first thing I'm going to do is simplify what's underneath the square root. All right, simplify all this junk. So I'm going to do that. Negative 11 plus or minus 11 squared I know is 121. So I have negative 4 times 2, which is 8. 8 times negative 8 times negative 6 is positive 48. And 2 times 2 is 4. Okay. Now, I can plug this part into my calculator, just this part that's underneath the square root, just like this. I could do that. Okay. You can do it in Desmos as well. All right, that's fine. That'll tell you what goes underneath here. All right, that'll tell me that it's negative 11 plus or minus the square root of 169. What is the square root of 169? That is 13. So what I need to do here now is set up two answers here. All right, I have x equals negative 11 plus 13 divided by 4, and x equals negative 11 minus 13 divided by 4. Well, let's do the plus first. Negative 11 plus 13 is 2. So I have 2 over 4, which is 1/2. Negative 11 minus 13 is negative 24 over 4, which is negative 6. So there are my two answers. Now it asks us to factor and solve to check our work. Yeah, we could do that. We're not going to. Let's just keep working. All right, so they have this nice little blurb here for you. I'd like you to take a second and read that. All right, I'm not going to go story time and read it to you, but take a second and read that. Okay, it just basically talks about what I just said to you in the last slide. All right, so this one, use a quadratic formula to solve the equation, round in 3 decimal places if necessary. Well, in order to use a quadratic formula, I needed 0 over here. All right, my quadratic needs to be equal to 0. So for that to happen, I'm going to add 5 to both sides. So now my quadratic is, I'm going to write this up here, 2x squared plus 5x minus 2 equals 0. So now I want to identify A equals 2, B equals 5, C equals negative 2. And let's just plug it in. Okay, plug it in. What I want you to do, pause the video, pause. And if you're not listening, pause and set it up. All right, pause and set it up and see if ours match. All right, there's my setup. Okay. Now I want you to pause again and simplify what's underneath the square root. Okay, so I got here -5 plus or minus 25 plus 16, because that's negative 8 times negative 2 is positive 16. Add them together, I get square root of 41. Okay, so just like last time, I need to split it. Unfortunately for us, there is not a square root of 41. So I need to split it. X equals -5 plus root 41 over 4. Then X equals, and I'm going to show you how to use a calculator to do this. All right, so I'm going to use Desmos. Okay, obviously, you can use Desmos, or you can use if you have a graphing calculator, use a graphing calculator. Okay, so I'm going to go, I got Desmos open. Here we go. -5 plus root 41, enter. And then I'm going to take this answer, copy it and paste it, and divide it by 4. How else would you do that? Oops, enter. Answer is right here, divided by 4. There's my first one. It's at 3 decimal places, so that's 0.351. I got 0.351. Same thing. Make this a minus root 41. Answer divided by 4. There is an answer button to do that. You can do this in your calculator as well, but actually you can just do it, -5 minus square root of 41. Press enter, I get this. Divide by 4. If you just hit divide by 4, it automatically includes the answer. All right, so you get the same thing, then that's going to be -2.851. So this would be an example of a time that I cannot actually factor to check my work. Why? Because these are not whole numbers. These are not whole numbers here. Okay, if these were like 1/2, and by whole numbers I mean clean answers. 1/2 is a clean answer. -6 a clean answer. 0.351 100 is not a clean answer. Same with this. That's not clean. Okay, why is it not clean? Because this is a root 41. If I don't have a perfect square here, it's not going to be a clean answer. I'm going to pause here. I'm going to stop here, and we're going to send you back to class. All right, that'll be it for today, and then we'll finish up.